This is just an example of an inverse function. Assume that we have a function from minus infinity to 0 to the real numbers, and it's defined by gx is equal to x squared plus 1. Our aim is to write down the domain and the range of the inverse of the function and find a formula for the inverse and prove that the g inverse is the inverse of g, and we want to find the derivative of g inverse. Now, we want to write it down the domain of G inverse. Domain of G inverse is given by the range of G. So the range of G is defined as x squared plus 1, where x runs from minus infinity to 0. So if you put the 0 here, then we will have 1. For any negative number here, we will obtain a positive number. So that will give us the interval from 1 to infinity. And the range of G inverse is defined as a domain of G. It needs to be a domain of G that is just a minus infinite to 0. That's clear, that's easy. So the second part, we want to find out the formula for G inverse. So for every element in minus infinite to 0, gx is equal to x squared plus 1. We let y is equal to x squared plus 1 and solve for x. So in this case, x is minus plus a square root of minus 1. Since x is in the range of minus infinity to 0, we consider the negative square root. Then g inverse x is defined as minus square root of x minus 1. Since I'm using x here, that needs to be x. So for all x from 1 to infinity. Now, next step, we would like to prove that G inverse is the inverse of G. That means this composite needs to be an identity in 1 infinity, and this composite needs to be an identity, should give an identity on the interval minus infinity to 0. So for all x in from 1 to infinity, the composite function g of G inverse x. So G inverse x is defined minus square root of x minus 1. That will be minus square root of x minus 1. And the G is defined as a square of this plus 1. That will give us x. That is the proof of the first one. Now, we consider that for all x's from minus infinity to 0, G inverse composite Gx. So Gx will be x squared plus 1. And now if we want to take the inverse, that will be minus x squared minus plus 1 minus 1. And this is negative, and then we left only the x squared. Now, this one needs to be minus. It is because minus x squared needs to be minus minus because x is in the negative from minus infinity to 0. For example, if you have a square root of 4, we need to think about the negative of it so that it will be in our range. So this means that we have negative that will give us the positive. So that is the identity on minus infinity to 0, which proves the second part. Now, the last part of the question, we would like to solve the derivative of the inverse of the function. I'm going to do that in 2 different ways. This is a straightforward way by just taking a derivative of the minus the square root of x minus 1. That was the definition of G inverse. So think about the square root as 1 over 2. So minus 1 over 2 will be comes out as a coefficient, and then the derivative of inside, which is 1, and then the power will get minus 1. So that will give us minus x minus 1 minus 1 over 2, which is basically minus 1 over 2 root x minus 1. So G inverse prime has a singularity at point x is equal to 1 on 1 to the infinity. So G inverse is not differentiable at x is equal to 1, but G inverse is differentiable if we think about the open interval. If we think about the open interval, then we can use the inverse function theorem, which can also be proved by I would like to give an explanation, applications of this theorem in this state. So I'm going to obtain this derivative by using an inverse function theorem. The inverse function theorem, just to remind ourselves what it was. So we were dealing with an open interval and assume that f is differentiable in the open interval and f prime, derivative of f, is not equal to 0 for any x in the open interval. Then the theorem tells us that f is a one-to-one. If any function is one-to-one, has an inverse. If inverse is differentiable at all points, this is not obvious, but this is the conclusion of the theorem. And the derivative of f inverse is given by this formula. F inverse, derivative of the f inverse is equal to 1 over f in derivative of f inverse x. Let's practice this part and try to find out exactly the same results as we've done in the last part of this question. So in the above example, gx is given by x squared plus 1. So if we take the derivative of this, we will have 2x. 2x is equal to 0 is equal to 0, has a 0 at 0. So we need to consider the open interval. Well, let's do that and consider the open interval minus infinity to 0 instead of the semi-closed interval minus infinity to 0. In this case, 0 is included. Here, 0 is not included. So G is this definition, and G inverse is in this definition. Now, since G prime x is not equal to 0 for every element in our in the domain of J, then we can use the inverse function theorem. Inverse function theorem says that the derivative of the inverse is the G prime derivative of G and of G inverse x. G inverse x is negative root x minus 1, and the derivative is 2 of x, whatever x is. So the x here is the minus root x minus 1. Place it. Then we found 1 over minus 2x minus 1. So this is exactly what we found here. So this is, we can apply the inverse function. We could find this result, or you can do it directly. So there are two ways of doing the third part of this question. That's all I want to say for this question. Thank you very much.